Now, one thing that's important to recognize is that the slope of the budget constraint represents a trade-off from pop to pizza. This is how many, essentially how many cans of pop we would have to give up in order to get an extra slice of pizza. The slope in this one is -2, and you can calculate the slope fairly easily by dividing the price of the good on the x-axis by the price of the good on the y-axis, and recognizing that this is a negative downward sloping line. So what we have here is that what we can see here from looking at the slope of the budget constraint is that every slice of pizza costs 2 cans of pop. Now, what we're going to do here is look at a few examples about what happens when things change. And the first thing we're going to look at is what happens when the price changes. And when the price changes, we can see that the slope must change. When we change the price of one of our goods, we can see that the slope of the budget constraint must change, because the slope represents the relative price of one good in terms of the other. So in our example here, what happens when the price of pizza falls from $2 to $1? What you can see here is that the budget line swings outward. Consumers feel wealthier because something that they like to purchase now has become less expensive, even though they haven't had any increase in income. Everything's cheaper, and so they feel wealthier. If you look at the graph, you can see the arrow indicating the shift in the budget line. The old budget line, the narrower, the inside red line represented the old budget constraint. But when the price of pizza falls from $2 to $1, the budget line swings outward, and you can see that the slope of the new line is equal to -1. The price of pop over the price of pizza. So for every on the new budget constraint, every slice of pizza costs us 1 can of pop. Now, if we look at the other scenario, suppose the price of pop rotated, the price of pop increased, and went from $1 per can to $2 per can. In this case, we'll get a rotation inward of the budget constraint. Now, I want to notice something that I skipped over on the last slide. If we consume only pizza, then we can still afford to consume 5 slices of pizza at $2 a piece. So that pizza intercept, that x-axis horizontal intercept, doesn't change when the price of pop changes. What the x-axis intercept tells us is how much pizza we can afford. But then we see when the price of pop goes up, the y-axis, the vertical axis, that intercept changes. We used to be able to afford 10 slices of pop if we spent all of our money on pop, but now at $2 a can, we can only afford 5 cans of pop. So what we get is an inward rotation of the budget constraint, and it pivots around the good that stayed at the same price. In this case, consumers feel poorer even though their income hasn't changed. They have their money doesn't go as far because the price of goods that they purchase has risen. Okay, what about a change in income? If a change in income comes about, the slope of our budget constraint will not change. The budget constraint will shift in a parallel fashion. The slope won't change because remember that the relative prices is what determines the slope. The price of a can of pop divided by the price of a slice of pizza divided by the price of a can of pop. That's what's going to tell us what our slope is. And when our slope doesn't change, then we're experiencing a parallel shift. In this case, what happens when your income falls from $10 to $8? In this case, the budget constraint will shift inward, reflecting the $2 fall in income. And you can see that we go from being able to afford 5 slices of pizza if we spent all of our money on pizza, down to 4 slices. And we go from being able to afford 10 cans of pop to being able to afford 8 cans of pop if we chose to spend all of our money on pop. So what we get when we have a shift in income is a parallel shift in the budget constraint. In this case, we're examining a fall in income, and we see that the fall in income means our budget constraint gets smaller. We get an inward shift in the line.